Hello everyone. Today we are starting off with the second part of theory of computation subject, that is context-free grammar. We have already covered finite automata. Now we are shifting towards push-down automata, and the grammar which is used for push-down automata is context-free grammar. Why do we need a grammar? Grammar actually defines a language. There are some rules which need to be followed to express or define a particular language. These rules are laid down in the form of production rules. Context-free grammar is used to generate a language called context-free language. Now, context-free grammar basically consists of four symbols T, V, S, and P. T means a finite set of terminals. V is a finite set of non-terminals. You may also find at some places that non-terminals are represented by a capital N, a start symbol denoted by S. It is a non-terminal symbol with which the grammar normally starts, and P is set of production rules. Now just take an example of this grammar. We have a grammar S tends to small a, capital A, small a, or B, A tends to small a. If we talk about this grammar in terms of T, V, S, P, here T is set of terminals. We have two terminals A and B. V is set of non-terminals. We have two non-terminals in this grammar, S and A, and P is set of production rules. Here we have three production rules. S tends to small a, capital A, S tends to B, and A tends to small. We will discuss about each and every symbol in detail. What does terminal includes? It includes all the lowercase characters early in the alphabets. Early in the alphabets means normally we consider A, B, C, and so on. Operator symbols, plus, percentage, punctuation symbols such as left parenthesis, right parenthesis, comma, semicolon, and all these things, and digits. So they are all considered to be terminal symbols. Boldface strings, ID or IF, they are also considered to be terminals. Now just consider this grammar. In this grammar, we have A as a terminal, B, semicolon, C, and epsilon as a terminal. Please remember, epsilon is always treated as a terminal. Non-terminal include all the uppercase letters early in the alphabets. The start symbol S is a non-terminal symbol, and lowercase italics names such as EXPR, STMT, when represented in italics, they are considered to be non-terminals. Now consider this grammar. In this grammar, we have three non-terminals, capital A, capital B, and S, which is the start symbol. What are production rules? They are set of rules which define the grammar. Say, for example, we have a grammar. In this grammar, we have three production rules. S tends to small a, capital A tends to small a, capital A, and A tends to small a. Now, what is derivation of a string? We say that we derive a particular string from a given grammar. We normally denote strings by small letter W. String W of terminals is generated by grammar if, starting with start symbol, one can apply productions and end up with W. That means we get a set of characters in the form of a string. Consider this grammar. Can we derive a sentence AAA from this grammar? Yes, we can. How? S is the start symbol. We say S tends to small a, capital A. Now we replace this capital A with small a. Since there was a production, capital A tends to small a. So we derive triple A from this particular grammar. Say, for example, we have a given input alpha, A, beta. If there is a production rule, A tends to gamma in a grammar where alpha and beta are arbitrary strings of terminals and non-terminals, we say that ultimately alpha 1, alpha 2 up to alpha n derived from some production rules will generate a sentence. If it is derived in single step, we represent this by a single arrow. If it is derived in 0 or more than one steps, then we show it by asterisk on the arrow. And if it is derived by one or more steps, we show it by a plus sign. Consider this grammar. In this, S tends to B is derived in one step only. S tends to ASA further tends to ABA. That means we have derived ABA in two steps. Likewise, we can derive in multiple steps triple A, B, triple A from the grammar which is given above. Now, What do you mean by sentence and sentential form? Sentence is a string of terminals only. Please remember these 2 points are very important whenever we are talking about entire context-free grammar. Sentential form is a combination of terminals and non-terminals. Say we have a production S tends to alpha and alpha contains non-terminals, then it is called a sentential form. In this case, S tends to ASA, AASAA, triple A, S, triple A, these are all sentential forms. If alpha does not contain any non-terminal, then we say that this is a sentence. Here, triple A, B, triple A is a sentence. Now we have two type of derivations. One is leftmost and another is rightmost. In leftmost derivation, we start deriving the string from the left side and convert all non-terminals into terminals. Whereas in rightmost derivation, we start deriving the string from right side and convert all non-terminals into terminals. Now just consider this grammar, and we are talking about leftmost derivation, how we will derive it. Say for example, we have to derive the string id plus id into id. Please remember here e is the start symbol. We start off with e tends to e plus e. Here we have replaced this first non-terminal on the leftmost side with the terminal, that is id. Now we have this capital E. We are replacing this capital E with capital E into capital E. In the next step, we will first convert this second non-terminal to the terminal and then move towards third non-terminal. Can we derive the same thing in this particular pattern? First, we are considering e tends to e plus e. Over here, we are creating a problem because we are placing this non-terminal with e into e, whereas we still had a non-terminal on left side. So this is wrong. For every derivation which we have, maybe left or right, we can always draw a parse tree. This parse tree indicates how this derivation has been achieved. Initially, we had the start symbol e. We have taken into consideration e plus e. So we have derived this. There is one leaf, that is plus. Now, since we are in leftmost derivation, first the left part of the tree will be considered. Next, we divide second capital E into two parts, that is capital E into E. Now, since we are again in leftmost derivation, we will convert first left E among the two into ID and then we will move to this. So, this is how we traverse in leftmost derivation. Now we come to rightmost derivation. For the same thing, same grammar, same string. We are scanning the string from the right side. So first we are converting this capital E into ID and then we are moving towards the left side. Why? Because we have to first convert all the non-terminals on right side to terminals and then move towards left. Next step is we will convert this capital E into ID. And in the last step, we will convert this last capital E into ID. If we consider the same thing in this particular format, will this be right? No, because in this case, we have taken into consideration this E on the left side before converting this particular E on the right side to the terminal. So this is wrong. Now we come to the parse tree corresponding to the rightmost derivation as we discussed in the leftmost. Now just see the difference. Initially we have E into E. Now we will start scanning from the right side. So we will first convert the rightmost E into ID. We will split the tree into two parts and then again we are converting the first right among both E and then the last one, that is the left one. Why we are doing this? Because we are into the rightmost derivation right now. Now we come to one more important concept of context-free grammar, which we say as ambiguous grammar. When is a grammar ambiguous? If it has more than one leftmost or more than one rightmost derivation for a given sentence. That means a given sentence can be derived by more than one ways, from leftmost or from rightmost. Now again consider the same grammar and the same string which needs to be derived. We have taken initially E plus E and in the end we have derived ID plus ID into ID. In the second case we have considered E asterisk E and we have derived ID plus ID into ID. Since we could derive the same string, that is id plus id into id, through two methods for a given grammar by two leftmost derivations, we say that this is a ambiguous grammar. Same is the case for rightmost. If we consider two rightmost derivations for the same string id plus id into id, so we say that this grammar is ambiguous. Please remember a very important point which I want to put up here. If any grammar has one leftmost and one rightmost, it does not mean that it is ambiguous. Grammar is ambiguous if it has more than one leftmost or more than one rightmost derivation for a given input string. The string should be same, the grammar should be same, and there should be more than one leftmost derivation or more than one rightmost derivation, which has been indicated in this slide as well as in the previous. We can summarize that major components of context-free grammar, that is terminals, non-terminals, start symbol, and productions, along with leftmost and rightmost derivation have been discussed, and ambiguous grammar has been discussed along with the example. In the coming slides, we will discuss how to generate context-free grammar for a given input. Thanks.